I think all of you have gone through this YouTube channel, BTCE, that in last semester also you are using that YouTube channel for recorded video. Okay, so this time also you need to see the same channel. Let me show you that. What is the channel name is there? So I'm uploading my everyday's lecture on that particular link. So you access it. Okay. Yeah, yeah. Yes. So this is my channel is yes. This is BTCE to live MEFGA. Okay. So those who want to see the recorded lecture, they need to go to this channel BTCE to live MEFGI. You need to go to the playlist, and in playlist there are a data communication and networking is there, and whatever the lab lecture, whatever I'm conducting, that is going to be updated as per the date wise. Okay, so whenever you want to see any previous recorded lecture, you please refer this link. Okay, so you will get majority of the idea. So if you want to note it down, kindly note this particular link, BTCE to live MEFGA. Okay, so whenever you want to see a recorded lecture, please follow this. So that's the one information that I want to share. Let we will go with our today's lecture. Start the PPT first. Okay. Yes. So we have the chapter number 1. Okay. Okay. So is the screen visible to everyone online?
Sir.
Okay. And again, I'm repeating to all the online students that I have also found that the same thing as I have said previously, like some of the students are coming to the lecture and after a few minutes they will left the lecture. Okay. So if I found such type of the student who is continuously doing this stuff, like coming for attendance, after a few minutes they will just run out from this lecture, so I will not give them attendance. So you need to be over here for the maximum time during the lecture. Okay. So what we have discussed in the last lecture, can anybody tell me? Yes. Analog and digital, we have discussed about the analog and digital. Yes, we have discussed about primarily we have discussed about two type of the analog signals, periodic signal and non-periodic signal, as well as we have discussed about the bandwidth of that periodic signal, non-periodic signal, and the frequency domain representation of both of them. Okay, so if we have a periodic signal like sine wave, so how the frequency response is going to look like, that we have discussed. And after that, discussing with that frequency domain, we have discussed about composite signal. Like consider that we are having many signals are there in one particular period, like multiple frequency of sine waves are there. So how those composite signal will look like and what are their frequency response. And at the end, we have discussed about the non-periodic signal, like we can say our speech signal. So in speech signal, you know that it is a range from 20 to, hello, is it audible? It's coming properly, my voice, or it's cracking?
Yes, sir.
It's coming
Properly.
properly. Okay, so might be some issue from that student side. So we have also discussed like that if we consider a speech signal. Okay, so in a speech signal, what you have, like you know that your speech is varying from 20 to 20 kilohertz, but there is no fixed frequency are there. So such type of the signal is considered as a non-periodic signal where the fixed type of the pattern you cannot identify. So what are the frequency response of that? So frequency response of such non-periodic composite signal is a continuous band. Okay, so this type of the stuff we have discussed in the last lecture, as well as we have gone with this number of levels with respect to the digital signal representation. Like if there are a number of level going to be 2, okay, then how the signal will look like. If you are having a number of level more than 2, then how the signal will look like, and why we need a more number of level to accommodate a more and more number of the data in a specific bounded band, or you achieve the higher speed with respect to same resource allocation. At that time, number of level you need to increase. So we have just stopped over here in the last lecture with the basic idea of digital signals. Today we need to discuss about that, what is a beat rate and how it's going to be calculated. So there is one few example, 2 or 3 example we have. So first example will be a digital signal having a 9 levels. Okay. So number of levels are 9. It is defined over here. How many beats are needed per level? So you need to find out that if the voltage levels are equal to 9, which is required to transmit. So how many beat you need to assign for each level? That's the calculation you need to do over here. So what is the solution for that? Like, we calculate a number of beats by using the formula, and each level is represented with that 3.1. So now what is the formula that we can apply over here? We can apply the formula over here, which is a 2 raised to power n. Okay. So we can say if number of levels L equal to 2 raised to power n. So number of levels is 9 equal to 2 raised to n. So what is the n? You need to take a NT log and then you can just get the answer. So if you take a NT log over there, like 9 equal to 2 raised to n. So n you are getting approximate 3.17. Okay. So that's kind of the actual answer you have. Like 9 equal to 2 raised to n. So n equal to 3.17. But 3.17 it's not a standard beat. How you can present 3.17 beats? Not possible. So either you can present how many beats? 1 beat, 2 beat, 3 beat, 4 beat. So like in kind of the regular integer in that manner, you need to present the numbers. So now what you need to choose? Number of levels in a number of beats in a level 3.17 right now it is required. So what we need to choose? 3 or 4? 4. Why is it 4? Why is it 4, not 3? Because minimum requirement is 3.17. So you cannot go down to 3.17. Okay, like minimum beat required, which is a 3.17 beats, तो आपको चाहिए ही चाहिए. तो आप 3 तो ले नहीं सकते. If you are taking a 3, then data is going to loss due to that 0.17 amount. But if you take a 4 beat per level, then extra bit is going to add it, but your information is get secure and it's not getting lost. Okay, so extra bit चले जाए ठीक है, लेकिन आपको data loss नहीं होना चाहिए. So what you are preferring in this situation, rather than to sending with the 9 level, you modified your system with the 16 level. And why 16 level? Because each level you are presenting with the 4 beat. And if we have a 4 beat, so how many levels you are required? 2 raised to 4 equal to 16. So rather than to using a 9 beat, which system you are adapting? 16 voltage level system you are adapting. So it is written over here like, however, this answer is not reliable or realistic. The number of beats sent per level need to be an integer as well as the power of 2. So that's why 4 beat can be represented at the 1 level. So why we cannot go with 3 and why we have choose the 4? This is the reason behind that. Okay. So if any time such type of the scenario is there, like you are having a voltage level to this one, slide is not full screen. Oh, sorry. Slide is not full screen. Just a second. Is it okay?
Yes, sir.
Sir.
Okay, chaliye, theek, yeah. So this is the reason that why we are not choosing a 3 level, but we will go with the 4 level. Second example that we have, assume that we need to download the text document at the rate of 100 pages per minute. Okay. So now there is an example of 100 pages per minute. What is the required beat rate of the channel? Okay. So whatever the beat rate that we are calculating over here, which is in a minute. Okay. So what we have, like, it is an average when we are considering that in one page there are 24 lines are there approximately, and in one line there are 80 characters are there. So one page 24 lines, one line 80 character, and such how many page we are sending in minute? 100 pages. And we can say to send a one character we are having a 8 bit. So how the bit rate is going to calculated, which will be calculated like this one: 100 multiply by 24 multiply by 80 multiply by 8. Okay, so 100 pages in minute, 24 lines in one pages, 80 character in one line, and one character of 8 bit. So that's overall it's going to be 1.636. It is not Mbps, it is going to be megabits per minute. Why? Because per minute we are calculating. So that's a little bit of mistakes over. But if I have changed the question like that, over here 100 pages per second. If I just change this minute with second over here, like this one, so if I'll just simply change it this one, so what's going to be happen? Now it is going to okay. Like what you are considering, now it is going to be a 1.636 Mbps. So to do the 100 pages per second, if you want to transmit, at least the internet speed you require is a 1.636 Mbps if you require such speed. Another example that we need to consider over here for our, oh, what's happened? Just a second. Monitor 1 has been disconnected. Okay, is it visible? Hello?
Yes.
Okay, yeah. So second example, what we have, second example, which is about transmitting a HDTV. Okay, so all of you are just seeing that HDTV at your home with your television set with either Sony or we can say MI or OnePlus. There are a very big techno, or we can say very high definition televisions available right now. And Tata Sky, other companies are also sending you the HD channels. Okay, so here there is an example of that. HDTV digital signal is broadcasting a high video signals, high quality video signals. That HDTV is normally is working on 16:9 ratio. Now, what is a 16:9 ratio? It means your horizontal with length of horizontal screen is larger, vertical is smaller. Okay, like you can say TV will be like this side is larger size and this is a smaller. Why is it so? Because your eye is also going to be behaving like that. Like if you just rotate the TV and you see the picture, what what type of the stuff that you can observe, like it is not suitable for your eyes because aapki aankh like this horizontal is wider, vertical is smaller. That's why television set is also made like this one. That's the basic scientific reason behind that. Now it's having a ratio of 16:9, and that HD quality is measured in terms of 1920 cross 1080 pixel. So whenever you just click the picture or click the video, this number will be there. If you want to capture the HD video, it will be 1920 cross 1080 pixel. So meaning of that, in a one frame, in a one image, there are a horizontally 1920 pixels and vertically 1080 pixels are there. While each pixel is made up of three colors: red, green, and blue. Okay. So when red, green, and blue three pictures are going to emit their colors simultaneously, so that image from the, or we can say that one pixel is going to generate their color. So what we have, like we are having a 1920 cross 1080 pixels are there, plus each pixel having a three colors, three sub pixels are there: red, green, and blue. And each pixel is going to be having a, I can say there are 8 bit is given for each and every pixels. So 8 bit for red, 8 bit for blue, 8 bit for green. Okay. Now there are one new term is there, which is a we can say ratio 30 times per second. Now what is the meaning of that? If you have seen any videos or if you have seen any commercial advertisement, then this is a kind of the very interesting thing to understand. Actually, there are no video. It's always capturing a multiple image simultaneously. So if you rotate a 30 pixel, we can say 30 images in front of your eyes, then it is considered as a movie. So whenever you are capturing any video of 1 second, it is nothing but it is capturing a 30 images in 1 second. Okay. So we can say whenever we are saying that we are recording the videos, it's nothing but it is capturing a different frames in 1 second. So for the standard display, you need to at least display a 30 frames in 1 second to consider it as a movement or as a video. Okay. So what we have a one frame made up of 1920 by 1080. In one frame, that much of the pixels are there. Each pixels is made up of RGB and each pixel having a 8 bit of the consideration, and such 30 frames are sending in a 1 second. So what is overall data rate is there? 1920 multiplied by 1080, such 30 frames you have, as well as in each pixel you are having a 24 bits, 8 for red, 8 for green, 8 for blue. So if you do the multiplication of all of them, you required at least 1.5 Gbps speed. So if you want to stream a HD TV on your set or through your satellite or through any particular cable, if you are doing this standard, you required 1.5 Gbps speed of internet. So is it such type of the high speed internet is available at our home? No, but still we are seeing the HD TV. So how is it possible? So those who are from TC1 don't give the answer because they don't know. Other students, those who are from TC1 don't give the answer. How is it possible? 1.5 Gbps ideally you require the speed, but such type of the speed is not available. Like in 20 Mbps internet broadband speed also you can see the HD movies in your YouTube. You can just stream it in your Chromecast, attach with your that your TV connected with Wi-Fi, and you can also see the HD streaming video. So how is it possible? 1.5 Gbps. Yes. One signal level is high, but signal level 1.5 Gbps है. एक सिग्नल लेवल में 8 फीट करो तो 0.2 Gbps तो चाहिए ना. 0.2 Gbps it means 200 Mbps speed you required. इतनी भी नहीं होती. So basic reason for that, that's already written in the downward. TV station reduce this rate into 20 to 40 Mbps through the compression. Now what do you mean by compression? As you have seen, whenever you record video, there are some extension is going to generate it. MKV, .mkv, .mp4. So this .mkv, MP4 is nothing but the compression standard. So whenever you are capturing that such type of the large information video, that particular standard will compress their data into such 20 to 40 Mbps. And then such 20 to 40 Mbps data is going to broadcasting. Okay, and that can be possible to broadcast with your, I can say with your satellite or with your broadband also. So if you are having a such broadband of 40 or 30 Mbps, you can stream that HD video continuously. Otherwise, it will take a time to buffering and then play, buffering and then play. But if you have a 40 to 50 Mbps, HD TV or HD video is going to be streamed properly. Okay. So this compression standard are there, which will reduce. It will not change their format. It will reduce into the smaller data size, and when it is come to your desktop box or whenever it is come to your reception side, it will again expand. So over there it will compress, over here it is expand. So likewise this HDTV broadcasting or communication. Now we will come for the periodic and non-periodicity of the digital signal. As we have seen, any question till now? In online, offline, any question till now? Please ask me. They compress. Yes, it is right. Ashish Mishra has given a right answer. They compress. Any question till now? No question? Huh? There are two type of the compression is there, lossy and lossless. Okay. So if you see the idea, like if you are having one particular pictures 1920 by 1080. Now if you just remove their alternative pixels and you just make that image too small, like if you have just removed that alternative pixel, so your entire size is reduced to half. And if you see, if you can say like that, from neighboring pixel you can predict the intermediate one. Like ये pixel ये है दूसरा, तो इसके बीच का आप predict कर सकते हो क्योंकि उतना ज्यादा difference नहीं होगा. So आप first ऐसा ही सोचिए कि आप alternative pixel को भी remove कर रहे हो, तो आपका ये जो कितना Gbps का जो speed था, वो पहले आधा हो गया. 1.5 directly reduced to 0.75 Gbps. Now, so reduced to half. Now ऐसा होगा कि like in 1 second. Is it like that 30 frame are all the 30 frames are different? एक सेकंड में 30 के 30 फ्रेम अलग अलग हो गए. There is no such possibility. So we can say what's going to change? Might be background going to same, just movement of that person only going to change. So what the compression standard will do, they will only capturing the moment and rest of the background it will take it from previous frame. तो 30 फ्रेम में से अगर आपने 20 फ्रेम ऐसी उड़ा दी जिसके बैकग्राउंड सेम है, सिर्फ मूवमेंट आप कैप्चर कर रहे हो, so again it is reduced to few megahertz. So likewise they are having such stage, like first they will remove that alternative pixels or they will present in some another manner, reduce to something, then it will take only movement, then it is reached to the final small amount. So whenever they want to get back the same thing, it will do the reverse process. Creating HD image, what they are saying that background it will take the same, movement it will add, alternative pixel again it will reconstruct, then it is again retried back as HD. So it will do the compression like this one. So original information does not getting any effect. It is as it is. The information is not get loose. Okay. Original information is there, but presenting in some another manner. Like you are using a zip file. When you are just compressing a large amount of folder into zip, what happened? Whatever the data inside of it is as it is, na? Overall representation is going to reduce. Likewise, it is going to happen same here. Okay. Any question? Any other question? Okay. So now, as we have discussed in analog, periodic and non-periodic signal, as well as in digital also, there are a periodic and non-periodic signal is there. So as we have seen, like in a digital, the first signal is going to be considered a time frequency domain of periodic digital signal, while second is a non-periodic signal. Now periodic signal digital will be, you can say like a square wave. So square wave continuously with specific type of the frequency, it is going to repeat it. While you can say the signal will be like 0, 1, 1, 0, 0, 1, 1, 0. So there is no fixed pattern in their beat, kind of the number of beats are coming. Please share this PPT in the group. Okay. So when where in which group I will share in this TC3 or I will upload it to Canvas? TC2 group. Okay. Okay, I will share it. Don't worry. Okay. So whenever we say you are considering your beat pattern 0, 1, 1, 1, 0, 1, 0. So if it is not fixed, so we can say such type of the signal consider as a non-periodic one. Okay. Now, what are the things we have whenever you talk about the digital signal? Whenever you talk about the digital signal, so digital signal always required a infinite bandwidth. Digital signal always required an infinite bandwidth. Why is it so? Because there are rules are there with frequency and time domain. As you have seen in a analog signal, if your signal is expanded in time domain, like sine wave कैसे आप represent करते हो continuously like this one. So if signal is expanded in time domain, frequency domain, there are only single spike. So if signal expanded in time domain, their frequency domain is very limited. If you compress your signal in time domain, your frequency domain will expand. Now consider like that, to create a such type of the square wave signal, just a one square wave signal, there is a limited time period you have. So whenever you're doing such type of the limited time period, to construct such type of the signal, you require the infinite number of frequency signal in that. Okay, so consider like that whenever you presenting a time limited signal where there are a shape is not just like a sinusoidal wave. Okay, or we can say to create a such type of the square wave, you require a multiple sine wave. You need to add it into that, and then it is creating a actual the pulsated signal. So when we can say the digital signal, whether it is a periodic or non-periodic, bandwidth you required are infinite. But if periodic digital signal are there, so as per the previous learning we have, periodic digital signal having a frequency response of discrete, while non-periodic digital signal having a bandwidth of or frequency response of continuous. So that rule is become as it is. If composite periodic digital signal having a discrete band, while non-periodic digital composite signal having a bandwidth continuous. So this rule that we have seen in this PPT is it remains same. Okay, पीरियोडिक सिग्नल है, composite signal बन रहा है तो उसका discrete frequency domain होगा. But if the signal is going to be a non-periodic, and you can say there are a non-periodic composite signal generated, their output is going to be a, or their frequency output is going to be a continuous. So now we will see for that why it is required a infinite bandwidth, or why required that much of the frequency component to do this one. So there are one of the example over here that according to with that signal and the band we are continuously seeing, but why to worry about a signal and channel bandwidth? Okay, like you are saying that you are driving any very good signals, like you are having one horse which is very capable, but you are loading so much stuff on their back, obviously that something is going to crash. Okay, अगर वो बैठ जाएगा या पूरा सब हिस्सा ही खत्म हो जाएगा. Okay, so that two type of the thing is going to be possible. Okay, so why we need to worry about that? As I have told you, infinite bandwidth. But why we need to worry about the bandwidth? Because we can say whatever the communication channel we are using, it is never going to infinite. ऐसा नहीं होगा कि लाइक रिलायंस वाले धीरू भाई गए कि भाई मुझे अपने बेटे के लिए पूरा एक कम्युनिकेशन सेटअप करना है जियो करके, और जितना आपका 4G 5G का बैंड है ना मेरे को चाहिए, दूसरा कोई कॉम्पिटिटर होगा ही नहीं. सो भले ही उसके नाम पे ये सब चलता हो, बट उसके यहाँ तो पूरा देश नहीं है ना. लाइक वोडाफोन वाले भी बोलेंगे कि भाई मेरा मुझे भी जियो, मुझे भी चलाना है 5G, मुझे भी 4G चलाना है. एयरटेल वाला बोलेगा मुझे भी 4G चलाना है. तो क्या करेंगे? लाइक सब पूरा बैंड तो धीरू भाई आपको नहीं दे सकते, तो मुकेश भाई आपको नहीं दे सकते. भले आपके बेटे का सेंटीमेंट है, लेकिन वी कैन नॉट डू सच टाइप ऑफ द थिंग. सो व्हाट वी नीड टू डू, we need to allocate this band to every company. थोड़ा बैंड आप यूज करिए, थोड़ा बैंड एयरटेल वाले यूज करते हैं, थोड़ा वोडाफोन वाले यूज करें, आइडिया वोडाफोन आप साथ में समझ लो, कंबाइन करके चलाओ. बट वी नीड टू डिस्ट्रीब्यूट टू ईच एंड एवरी कंपनी. So we can say we don't have the infinite band, we have a limited band. So whatever the signal we are inserting in this one, it should not be a infinite. So आप ऐसा कर रहे हो, आप बैंड लिमिटेड लेके बैठे हो, सिग्नल आप इनफाइनाइट बैंड चाहिए ऐसा ट्रांसमिट कर रहे हो. So obviously there are a problem is there while we are receiving something. Okay, so there is a basic stuff we have, like a digital signal is composite analog with an infinite bandwidth, while baseband transmission means sending a signal over a limited band, or we can say channel, without changing the digital signal into analog. मतलब कि आप डिजिटल इंफॉर्मेशन चेंज नहीं कर सकते हो. आपने 1010 जो सीक्वेंस भेजा है वो तो सेम एज इट इज रहना चाहिए, बट आपको उसके लिए जो इनफाइनाइट बैंडविड्थ है उसका भी कुछ करना पड़ेगा. सो यू हैव अ you have a problem over here, you should not change their appearance, but you need to limit your signal band. So baseband transmission required a low pass channel. So there are two type of the channels. We have wideband and narrowband. So what do you mean by wideband and narrowband? It will be look like this one. We can say low pass channel with the wide bandwidth, or we can say low pass channel with the narrow bandwidth. You can consider like that. If I'm saying that wideband, it means I can say 0 to 20 megahertz. While I can say with respect to 0 to 20 megahertz, what is a low band? 0 to 10 megahertz. So with respect to one particular band, if you are allocating entire spectrum, that we can say the wideband signal. If you are taking a very narrow signal, or we can say narrow band you are using, that's considered as a narrow bandwidth signal. So what is the problem actually arise? Problem is arising from by presenting this domain. So if you are using such type of the non-periodic digital signal, so non-periodic digital signal required the infinite bandwidth. Okay, but your channel is having a limited band from F1 to F2. So what is going to be happen whenever you pass this type of this signal from this limited channel, your output will be look like this. So we can say whatever the shape of your original signal might going to change. Okay, like ऐसा है कि आपके पास मोटर 5 की है और आपके पास पाइप 2 का है. ठीक है, 5 की मोटर का फोर्स आप 2 के पाइप में लगाओगे तो क्या होगा, जितना कैपेसिटी होगा उतना उसमें ट्रांसमिट होगा, रेस्ट ऑफ देम इज गोइंग टू फेडेड आउट और बाहर निकल जाएगा. That type of the thing happen over here. You have a limited channel sending an infinite signal, something going to be loose at the end. So why there is an infinite bandwidth? So over here there is an example of that. Like we can say there are a bit rate is mentioned over here. Digital bit rate n, or we can say there are if you are having a digital bit rate n, so we can say there are a 0 0 0 0 amplitude. I can say there are a straight signal. So their analog will look like this one, straight line. If your digital bit rate is going to be n with respect to the analog f equal to n by 4, I can say whenever you can say 0 0 1 0 1 0 0 1 1, or I can say 1 0. So these are the overall possible changes are there. Like I'm having a 0 to 7, 3 voltage level I am using. So I can say that every time 0 0 0 0 0 1 0 1 0. So you can say there are different pattern are there, which is created like this one. For 0 0 it is a straight. For 0 0 1 there is 1 is there over here. Then 0 1 0 0 1 1. Likewise there are a different voltage level is presented. Now only and only if you can say bandwidth you are saying analog f equal to 0. I'm coming to that one. Analog f equal to 0, phase is going to be 180. Meaning of that, to present this signal, to present this level, what type of the frequency you require? F equal to 0, because there is a straight line, no frequency. So what you required? F equal to 0 with phase equal to 180. Why it is a 180? Because you are considering that signal sinusoidal wave, and this is a downside. So whenever it is an upside, what you have, like starting from sinusoidal wave starting from 0, 90, 180, 270, and then 0. Okay, so here it is a 0 is present with the downside signal, so you require a phase of your DC signal with the 180 and your frequency going to 0. Actually there is a no meaning of phase over here because frequency itself 0, so going to the down. Now to do this 001, now taking a signal 001, what type of the frequency you require? You require the frequency n by 4. Why it is n by 4? Because 2 pulse is coming, like out of these 3, 2 pulse is going with the down and one of the half pulse you are using from the another cycle. So आपके पास पूरा cycle है 0, 90, 180, 270 and again 0. Out of that, what you require right now? 2 boxes of the down cycle and 1 box is from the up cycle. So when you calculate that, what is the data rate with respect to that? It's going to be a n by 4. And phase you required with the 180. Or simple, you can identify whatever the pulse you have. According to that, draw the sinusoidal wave. अब इसके अकॉर्डिंग साइनोसॉइडल वेव किस तरह से डिसाइड करोगे? सो इट्स गोइंग फ्रॉम डाउन टू अपवर्ड. If you are having a signal like 010, so if 010, so what is the beat rate you required? N by 2. क्योंकि 01010, if you consider, so that beat rate is N by 2. If you can say 0011, 0011, so beat rate is N by 4. So that's why whenever there are a intermediate beat change, 010, or we can say 100, sorry, 101, 010, at every time you require a frequency component of N by 2. And whenever such type of the variation will be 001, 100, okay, such type of the time, or 110, 110, okay, at that time you require the beat rate of N by 4. So overall you can say to present this 3-bit data varying from 000 to 111, at least you need to apply a 2 frequency component, 0, N by 4, N by 2. Are you getting my point over here or not? Anybody having question in mind? What is this harmonic, or what are the
फ्रीक्वेंसी का एक बार समझा दो ना फिर से.
yes?
N/2 N/4 वाला फिर से
N
एक
by
बार.
4, N by 2 वाला, yes. अब आप देखिए यहाँ पे, like what is the alternative beat rate? Like if I can say your digital beat rate is N over here, okay, if digital bit rate is N and bit rate pattern is 010101 like that, so we can say you need to do the alteration in a frequency with N by 2. क्योंकि आपको क्या करना पड़ेगा, एक एक पल्स आपको किसके लिए करना पड़ेगा? पॉजिटिव के लिए, एक नेगेटिव के लिए. So you can say if your digital bit rate is N but your variation in pattern is 010101 like that, so your bit rate is divided by 2, क्योंकि हाफ टाइम के लिए आपको 0 चाहिए, हाफ टाइम के लिए आपको 1 चाहिए. So frequency is going to be a N by 2. Now if it is going to be like this one, 001 or 011 or 100, or we can say 111, sorry, 110. So how it will look like? There is a beat pattern will be like this one, 110, or we can say 11, 011, 011 like that. So whatever your frequency rate is there, what you need to give N by 4 time, you need to give it to them. जैसे किस तरह से हमने 0101 पे हाफ फ्रीक्वेंसी की, like for that 110 there are a 2 beat is repeated simultaneously, 1100 1100, or we can say 0011 0011. So for that your beat rate is going to divided by 4. 0101 के लिए divided by 2 होता है, तो 0011 0011 के लिए divided by 4 होगा ना? Are you getting my point or not?
Yes sir.
101, हाँ, हाँ, यहाँ पे बोल रहे हो 5th और 6th में दिस वन और दिस वन, बट यहाँ पे आप बीट रेट देखो ना, यहाँ पे आपको क्या चाहिए? 100, तो ये आगे भी 1 होगा ना? आप एक बीट पैटर्न पकड़ रहे हो ना, 100, तो ये कैसे पैटर्न बना होगा? 100 100 1100 लाइक दैट, क्योंकि फर्स्ट बीट आपका एक और आगे है ना 1, आप 100 का ही पैटर्न ले रहे हो ना. आप पहले ये बीट पैटर्न पकड़िए, 01010101. अभी मुझे 3 बीट कोई भी इसमें से चूज करने हैं, like to getting the, so what I will choose 010 or 10101. Now another pattern I have 0011 0011. Now how many possibilities are there? 0011 001 or 110 or 011 or 100. These all are possibilities. Now assign the beat to them. Like आप 0011 को आप साइनोसॉइडल वेव दोगे तो क्या होगा? 00 में थोड़ा अप जाएगा, 11 में थोड़ा डाउन जाएगा. तो 0011 में पूरी साइकिल है, बट आप यहाँ पे प्रेजेंट क्या कर रहे हो? 011 ओनली, तो ये तो 90 डिग्री से होगा ना. लेट मी ड्रॉ इट ओवर हियर. whatever the snapshot or block that we have taken. आप ऐसा ऐसा देखिए 1 1 1 0 0 है, तब इसके लिए ऐसा सिग्नल बनाओगे ना कि लाइक इसके लिए ये हाई गया और बाद में ये डाउन होगा, लेकिन आप अभी कैप्चर इतना ही कर रहे हो, तो उस हिसाब से यहाँ पे जो फेस होगा 90 वो आएगा ना। अभी दूसरा देखिए 0 1 0 1, अभी इसके लिए आप कैसे प्रेजेंट करोगे, लाइक इट इज गोइंग टू अप डाउन अप डाउन। अभी इनमें से मैं 3 बीट लूं तो क्या मैं कंसीडर करूंगा, यही करूंगा ना। सो आई कैन से एट दैट टाइम आदर इज दिस फेस इज गोइंग टू 0 और 180। हाँ अल्लाह हाँ नहीं 1 1 0 0, ये फिफ्थ पैटर्न जो आप सोच रहे हो यहाँ पे, ये पैटर्न कहाँ से मिली होगी, 1 1 0 0 में से। एक 1 आगे का नहीं लिया, 1 0 0 हमने लिया। अगर आप यहाँ पे सेवंथ पैटर्न देख रहे हो तो ये क्या होगा, 1 1 और आगे और एक 0 यहाँ पे होगा, लेकिन आप 3 की पैटर्न के लिए क्या ले रहे हो 1 1 0, तो 1 1 के लिए तो ये 0 से स्टार्ट हुआ है यहाँ पे, दैट्स व्हाई फेस इज 0। समझ गए आप? यस। So on we can say on an average, or we have considered only 3 bit changes. Like you can say there are a possibilities will be 0 1 0 1, or I can say 0 0. Now how many possibilities are there? If you consider the number of bits, तो अभी 4 बीट का देखो. So you can say if you are having a 4 bit simultaneous, so 0 0 0 0 0 0 16 such type of the possibilities are there. And to do that 16, what type of the component you require? n by 4 है तो n by 8 चाहिए. Now you can say if you are having a such type of the large bit stream, तो उसके लिए कितनी पॉसिबिलिटीज हो गए, 4 बीट की पैटर्न पॉसिबल है, 3 बीट की, 6 बीट की, 9 बीट, 8 बीट, multiple possibilities are there. So to present all the signal, what component you require? You require n by 4 also, n by 2 also, n by 8 also, n also. So you require the infinite number of harmonics to present that same signal. And that is why whenever such signal which is required the infinite harmonics, obviously it is required the infinite band. So this is a reason why it is saying like that. If you are having a signal like more than that, if you are having like n by 4, n by 2, 3n by 4, 3n by 2, 5n by 4, 5n by 2, according to that, to create a actual amount of the digital signal, to create an actual type of the digital signal, likewise 0 1 0, you need to add n by 2 3n by 2 signal also, you need to add n by 2 signal, n by 2 3n by 2 5n by 2. So as more and more number of harmonics you are adding to your signal, your square pulses become tends to the square. पहले आप साइनोसॉइडल को स्क्वायर बनाने के लिए आपको उसमें मल्टीपल हार्मोनिक्स ऐड करने पड़ेंगे, तब जाके वो ऐसा परफेक्ट स्क्वायर बनेगा. तो यहाँ पे हमने 5n by 2 तक सिग्नल ऐड किए, सो यू गेट अ सच टाइप ऑफ द हार्मोनिक्स. बट इफ यू आर एडिंग मोर एंड मोर, इट इज बिकम मोर स्क्वायर्ड. So if you are adding more and more, it means it is consuming as much as infinite bandwidth, and that is the reason why signal, digital signal, which is required the infinite bandwidth. Why? To create a such digital signal, we require the infinite harmonics of sinusoidal wave. Okay, that is the reason. So you can say if the baseband transmission, the required bandwidth is proportional to the beat rate. If we need to send the beat faster, we need a more bandwidth. Like if your beat rate is 1 kbps, and if you are using only one harmonic to present that one, so that required 500 hertz. But if you are adding the harmonics in that to make it more precise square, so it required 1.5, 2.5 kilohertz. If your beat rate is 100 kbps, and if you are adding more and more harmonics in that, it is required the 250 kilohertz. And if you are adding more and more, it's required the more and more bandwidth is required. So we can say if you want to do a proper proper square, perfect square wave, if you want to transmit, mandatory you need to give a more harmonics, and mandatory you require the large band. That is the overall conclusion of this. Anybody having any doubt? यदि मैं क्वेश्चन किसी को पूछूं कि लाइक व्हाई डिजिटल सिग्नल रिक्वायर द इनफाइनाइट बैंडविड्थ, सो यू शुड स्ट्राइक दिस वन. ओके, ये समझना जरूरी है. चलिए. So now there are example like what is the required bandwidth for low pass channel if we need to send 1 Mbps by using a baseband transmission. So the answer is going to be depend on what is the accuracy that you require. So the minimum bandwidth is going to be bit rate divided by 2 because half beat for 1, half for 0. So that's why it is directly divided by 2 like 1010 pattern you are using. So bit rate going to be 500 kilohertz. A better solution to be use a first band and third band, so you need to add a 3 harmonics, so it's required 1.5 mbps. Still, if you want to do the better solution, first, third and fifth harmonic, it is required the 2.5 mbps. ठीक है, 1 mbps का डेटा ट्रांसमिट करने के लिए आपको 2.5 mbps का बैंड चाहिए. तो जनरेट कम कर रहे हो, ट्रांसमिट करने के लिए ज्यादा बैंड कंज्यूम कर रहे हो, तो ये तो कुछ गलत हो गया, ऐसा तो नहीं होना चाहिए. Now to do that, what are the stuff that is going to be possible? Okay, that is going to be a solution over here. So this is also the one of the example over here. But coming to that, if you are having a band pass channel, now what is the solution? If we don't have excessive band, आप 1.5 mbps जनरेट कर रहे हो, बैंड आपको 1.5 mbps का ही मिलेगा, ज्यादा हम नहीं दे सकते. तो अभी क्या करना चाहिए? We have the kind of the curiosity, we have the innovation question over here that how it is possible. So that possible is through a digital to analog converter. Okay, digital to analog converter. It means whatever the digital signal is there, you convert it into the analog. And how it is going to convert it? There are several digital to analog converter technique are there. PAM are there. We can say ASK are there. FSK are there. QPSK are there. It's nothing but whenever there are a high signal, whenever there are a high amplitude signal, their amplitude is going to also high of one sinusoidal wave. तो अब क्या कर रहे हो? आप एक sinusoidal wave, high frequency का sinusoidal wave आपके like with your digital signal you are multiplied with, आप उसके साथ multiply कर रहे हो. Like there are digital signal coming from one side, one frequency is generated, you are multiplied it both. So what happened? Whenever there is a one with that digital signal, your amplitude is also going to higher. Whenever it is zero, your amplitude is going to zero or something two level you are saying. So overall, your signal is converted to this one. Now, if you see the bandwidth of the signal, अगर आप ये सिग्नल का बैंडविड्थ देख रहे हो तो ऑटोमेटिकली इट इज अ टाइम लिमिटेड बैंड. क्यों? क्योंकि ये सिग्नल जनरेट करने के लिए आप कोई एक फ्रीक्वेंसी यूज कर रहे हो. लेट्स टेक 2.5 मेगाहर्ट्ज you have used. So overall, what is the overall situation you have? Overall, you are using a 2.5 mbps signal only. और ये जो वेरिएशन हो रहा है एम्पलीट्यूड के लिए, इट इज रिक्वायर्ड अ लिटिल बिट ऑफ साइड बैंड कि भाई 2.5 mbps से थोड़ा इधर जाएगा, थोड़ा इधर जाएगा. But now your digital signal actually you are superimposing on analog signal, and due to that your band is going to limited. तो previously जिसके लिए आपको infinite band चाहिए था, उसका आपने क्या कर दिया? Limited band by doing the modulation. So that's why whatever your signal is there, it is get band limited from F1 to F2. Now you are sending with F1 to F2 band limited channel. It is received properly because now there is a no loss because you have fulfilled the criteria of bandwidth. And now again you need to do the reverse process, analog to digital conversion. तो आपको क्या करना पड़ेगा? You need to put a comparator, okay, or you need to put a demodulator. If amplitude of this analog signal is higher, then you need to set it as a 1. If the amplitude of that analog signal is lower, you need to set it as a 0. So जो आपने डिजिटल सिग्नल भेजा था वो फिर से यहाँ पे रीट्राई हो गया. So that's why your shape of your digital signal it is not disturbed at all. वो भी डिस्टर्ब नहीं हुआ और यहाँ पे जो बैंड का जो रिक्वायरमेंट था, इनफाइनाइट बैंड हम नहीं अफोर्ड कर सकते, so that band is also you have saved. So this is the why you require the modulation. Okay, convert from one analog to digital or digital to analog. This is the reason why we can use that. Is it okay with everyone? So we are going to cap this stuff over here up to this particular point, and in the next lecture we will discuss with the distortion and all that. Now all of the students are on the same pitch. Okay, TC1, TC2, TC3, all are in a same lecture. So this video lecture I'm going to upload it today or by tomorrow morning on that YouTube link, so you can refer it. Okay, and PPT also I'm going to upload it. So everybody just write their enrollment number and name, and then if you have any doubt query, you can ask me. We have a 4 minutes of time, or in one page you, or let me just write it over here also. So yes, TC1. TC1, only student from TC1, last 3 digit of enrollment number. 21, 021, 66, 57, 171, 166, only 26. TC1, 59, 65, 70, 79, 162. From TC2, 132, 88. Anybody else? TC2. From TC3, TC3, 2, only 2. Yes, next. 12, 20, 0, 11, 18, 18, 15, 14. Okay. Anybody else? Remaining? Chaliye, theek hai. So you can leave after that. If you have any question, you can ask me.